Human-induced seismicity in the lithosphere. The Earth's outermost layer, which contains the crust and the upper mantle, is known as the lithosphere. The lithosphere is broken up into massive plates that slowly but constantly move due to convection in the Earth's core. These plates interact by colliding, sliding past, and spreading apart from each other. This interaction causes hotbeds of seismic activity along these plate boundaries in the form of volcanoes and earthquakes. Although most seismic activity occurs at or very close to these boundaries, volcanoes and earthquakes do occur towards the interiors of these plates. The vast majority of this continental seismicity is natural, but human activity can sometimes trigger earthquakes. Human-induced seismicity is capable of producing dangerous and destructive earthquakes. Two main ways humans can cause significant earthquakes is through mining-induced seismicity and reservoir-induced seismicity. Mining-induced seismicity is caused by abrupt changes in pressure on faults and fractures deep underground. Large seismic events are usually generated by mine collapses. Seismicity is also associated with blasting in mines, quarrying, open pit mining, and flooding of inactive mines. Reservoir-induced seismicity is caused by the massive amount of pressure that the body of water puts on underlying faults or structures. The significant increase in stress can lead to sudden movements along the fault or fracture, resulting in earthquakes. One reservoir-induced earthquake that is widely accepted is the 1967 magnitude 6.3 earthquake in Konya, India. This earthquake killed 177 people, injured more than 2,000, and left 50,000 people homeless. Some argue the connection between human activity and earthquakes, especially when the earthquake in question occurs near plate boundaries. One such case of skepticism is the 2008 magnitude 7.9 earthquake that occurred in Wenchuan, China. This area is naturally seismically active, but many researchers believe this earthquake was caused by the nearby Zipingpu Reservoir, which was just filled 3 years prior to the earthquake that claimed nearly 90,000 lives. Other sources of human-induced earthquakes and tremors include hydraulic fracturing, wastewater injection, and geothermal energy extraction. All of these earth movements caused by humans occur in the lithosphere. Human-induced seismicity affects the lithosphere by putting pressure that would not occur naturally on faults and fractures, potentially leading to earthquakes. Human-induced seismicity affects the frequency, severity, and location of earthquakes. Earthquakes and tremors caused by human activity occur worldwide, but certain areas will be at an elevated risk for human-caused seismic disasters in the coming years. Two countries that will be in an elevated risk for these disasters are China and India. These countries are building large new reservoirs for municipal water supplies and hydroelectric power to support both of their rapidly growing populations. Because these reservoirs will be adjacent to large cities, the effects of a significant seismic event would be catastrophic. People are affected by human-induced seismicity all over the world. The people affected the most are the people living nearby newly constructed dams and reservoirs, people living by mining operations, people living near fracking and gas extraction sites, and people living near wastewater injection facilities. Human-induced seismicity relates to physical geography in that it goes hand in hand with geomorphology, which is one of the three main components of physical geography. Geomorphology is the study of changing landforms and their processes. To address the problem of human-induced seismicity, geologists are looking into finding ways to determine where faults, fractures, and other sensitive areas may occur. More research into human-induced seismicity will help solve this environmental problem.